Chapter 42, we are solving quadratic equations by factoring. This expo is special for special cookbook equations. This development, this exposition, is for special cookbook equations. The left member of the equation, ax squared plus bx plus c, the right member is 0. The left member is supposed to be factorable. If you cannot factor the left member, you cannot do it this way. The key to the solution lies in setting a product equal to 0 on the left, so factoring. Then any factor can be 0. 0 times 3 times x is 0, regardless of the value of x. X minus 4 times 2x plus 3 is equal to 0 if x is 4. 4 minus 4 is 0 times whatever this is. Or if x is negative 5 over 2. 2 times negative 5 over 2 plus 5 is 0. 0 times whatever this number is 0. And 4 minus 4 is 0. So this is equal to 0 times 13. There's an equal sign missing here. And if x is negative 5 over 2, this becomes 0. So 13 over 2 times 0, which is 0. Just what I said. And then in the nature of examples, we want to solve 5x times x minus 9 times x plus 0.7, which is 0. This can be 0 if x is 0. 0 times something is 0. X minus 9 is 0, so x can be 9. You get something times 0 times something. Or x can be negative 0.7. You get 0.7 minus negative 0.7, something times 0, which is 0. So any one of these three factors can be 0. We get three possible answers. We want to solve this equation. You want the greatest common factor first. The greatest common factor is x. You are left with 5x minus 3. So either x is 0 or this factor is 0, which means that x is 3 over 5. You want a 0 on the right. So the first thing you do, you subtract 10 from both sides. You factor, greatest common factor is 1. Factor gives you x minus 5 times x plus 2. Solution, x is 5, x is negative 2. Example 4. We want a 0 on the right, and we want a sum of the second degree and the first degree, so we're going to distribute before we do anything else. That gives us x squared plus 8x plus 15, which is 0. The 15 came from adding 15 to both sides. This factors as x plus 3 times x plus 5, which is 0. Solution, x is negative 3, x is negative 5. Example 5. A sheet of paper measures 11 by 8 inches. I know it's 8.5, but let's leave it at 8. A uniform border surrounds the printed material. What is the size of the uniform border if the printed material is 54 square feet? Now a diagram would have come in handy, but I don't have one. So let x be the measurement of the printed material. Then 11 minus 2x, you have x on one side, x on the other side, a border here, a border over there. So the measurement is 11 minus x, or 8 minus x, which becomes 4x squared minus 38x plus 88. That is supposed to be 54 square inches. Subtract 54, factor out the greatest common factor, which is 2. Find the two magic numbers, negative 2, negative 17. Factor out x minus 1, and then you're left with 2x minus 17. So the border can be either x is 1 or x is half of 17, 8.5. This latter result cannot be a solution because it is larger than the width of the paper. Can you imagine 8.5 inches on this side, 8.5 inches on that side, and you're left with some number, if the total from that end to this end is just 8 inches, that's impossible. So the border is 1 inch.